Hi, my name is Jakob and I'm excited to present our work Explanations, Fairness, and Appropriate Reliance in Human AI Decision Making. This is joint work with Maria De-Arteaga and Niklas Kühl. Over the past years, we've seen a variety of different examples where AI systems have been used to inform high-stakes decisions, but at the same time have been perpetuating and reinforcing harmful societal inequalities. For that reason, policymakers and practitioners have been calling for greater human oversight in such AI-assisted decision-making setups, making users the quote-unquote last line of defense against AI failures. Now, how such a last line of defense typically looks like is as follows. We typically have an AI system that issues certain decision recommendations to a human. That human then takes these recommendations and either adheres to them or overrides them. And we typically call the act of the human of adhering to or overriding AI recommendations their reliance behavior. In many cases, it is a very, very difficult task for that human to decide when to adhere and when to override a given AI recommendation. Now, to this end, explanations have been claimed to enable humans to complement the AI, ultimately leading to fairer decisions. This is a quote from a news article from 2022 that claims that companies are using explainable AI to make sure that they're making fair decisions. However, based on some of our own prior work, we have found that many claims on the fairness benefits of explanations are overly simplistic, they are in part lacking normative grounding, and importantly, they're not backed by empirical evidence. Now, for that reason, in this work, we conducted an online user study to examine the effectiveness of feature-based explanations with respect to enabling humans to enhance fairness of AI-assisted decisions. Now, in our study, we consider the task of AI-assisted occupation prediction, which prior work has shown to be susceptible to gender bias. Now, concretely, in this study, we consider the task of AI-assisted binary occupation prediction from short bios, such as the bio here on the slide. And the task is then to decide whether this bio belongs to either a professor or a teacher. Now, for this study, we are using bios of both women and men, professors and teachers from the bios dataset. We also know that historical stereotypes associate the occupation of professor with men and the occupation of teacher with women. And this is reflected in our data as well, where we see that more men are professors and more women are teachers. Now, in our study participants are being shown different short textual bios, as well as an AI recommendation that would predict the bio to belong either to a professor or a teacher, as well as an explanation. The participants are then tasked with either to adhere to the AI recommendation or override it, and ultimately we are measuring the implications of that reliance behavior on distributive fairness. Now, to issue AI recommendations to study participants, we're training two binary classifiers on disjoint vocabularies. The first classifier that we're training is leveraging task-relevant words to predict whether a bio belongs to a professor or a teacher. And the words that this classifier is using are ones that appear statistically most often in professor or teacher bios. And this includes words such as faculty, kindergarten, PhD, and others. Now, the gender classifier is a classifier that uses words that are most predictive of gender, including gender pronouns and other words that are gendered, such as husband and wife. And that classifier uses these gendered words to predict whether a bio belongs to a professor or a teacher. Now, the reason we train two different classifiers is inspired by prior work. Prior work has found that people tend to perceive AI systems that are making explicit use of sensitive information, such as on people's gender, as unfair. On the other hand, when a classifier makes no explicit use of gendered information, then people tend to perceive such systems as much fairer. However, The effects of people's perceptions on their reliance behavior, as well as any downstream implications for distributive fairness, are unclear, which is where our work complements these prior works that have studied fairness perceptions. In conjunction with the AI recommendations, the study participants are also provided with feature-based explanations, which have been claimed to enable fairness assessments. Now, for each of our two classifiers, we're generating these feature-based explanations that are highlighting predictive words either towards professor when they're highlighted in blue, or towards teacher when they're highlighted in orange. Now, the classifiers that are issuing decision recommendations are much more likely to predict women as teachers and men as professors, which is in line with what prior work has found. Concretely, we know that gender bias in occupation prediction typically manifests itself in higher false positive rates for men and higher false negative rates for women in the AI recommendations, if we assume that a positive prediction is that of a professor and a negative prediction is that of a teacher. Concretely, an error rate distribution in AI recommendations of a biased system could look like this, where the AI system is much more likely to recommend men who are teachers to be professors, a false positive, and women who are professors to be teachers, a false negative. Now, in order for the human to counter these stereotypical AI recommendations, they would have to rely on these recommendations in a certain way. Concretely, they would have to reduce false positive predictions for men, meaning that they would have to override cases where the AI recommends men teachers to be professors, or they would have to reduce false negative predictions for women, meaning that the human would have to override cases where the AI recommends women professors to be teachers. We study whether explanations can facilitate that type of reliance behavior in a randomized between subject study, where we assign 600 study participants to one of three conditions. The task-relevant condition is the condition where study participants see AI recommendations and explanations from the classifier that uses task-relevant words. In the gendered condition on the right-hand side, study participants see AI recommendations and explanations from the gendered classifier that uses gendered words. And we also include a baseline condition where no explanations are provided. Now, in each of these three conditions, participants see both correct and incorrect AI recommendations in line with gender stereotypes, according to the error rate distributions that we just talked about on the previous slide. Also note that the AI recommendations and the scenarios that participants see in each condition are identical. Now, when we look at the results between conditions, we see that explanations do not reliably lead to a reduction in errors, which was a prerequisite for countering stereotypical AI recommendations. Quite the opposite. For min bias on the left-hand side, we see that false positive errors even increase in the task-relevant condition. What we instead observe is that feature-based explanations lead to either an increase or a decrease in overrides, depending on which words are highlighted. Now, concretely, we see that people in the gendered condition are overriding more AI recommendations compared to the baseline, whereas people in the task-relevant condition are overriding less AI recommendations than in the baseline. However, in both cases, the increase or decrease in overrides is independent of the correctness of AI recommendations. From a fairness perspective, however, it is problematic to override AI recommendations based on the use or disuse of sensitive information of the underlying AI system. In fact, we know that the idea that an AI system is fair if it does not explicitly consider sensitive information, which has sometimes been called fairness through unawareness, is flawed, which is primarily due to the fact that sensitive information can be redundantly encoded in other features. However, what we find in the study is that feature-based explanations are a human-in-the-loop operationalization of this flawed idea of fairness through unawareness, where people override AI recommendations more when they learn through explanations that the system is using sensitive information, and they override less AI recommendations when the explanations do not explicitly highlight the use of sensitive features. Now, the main takeaways of our work are as follows. We find that feature-based explanations do not reliably enable humans to identify and override AI errors. Instead, we find that these explanations may foster a shifting of errors depending on which words are highlighted, task-relevant or gendered. And this means that feature-based explanations are not a reliable mechanism for enhancing distributive fairness in AI-assisted decision-making. Thank you very much.